Hello, I'm Kevin, a Brazilian architect and urban planner working mainly with public spaces, public-private partnerships, and BIM.
And I'm Lucas Meirelles. I'm also a Brazilian architect and urban planner working with research and public policy.
Together, we made this project using ArchiCAD, Rhino, and Grasshopper.
This project's main goal was to create an arena that could be used for multiple occasions, should be able to host concerts, football and basketball games, and other types of events. Our main challenge was to represent all of these occasions, creating images illustrating the main events and the audience reaction.
Okay, so let's go to the making of. The modeling software here is Rhino. The reason is for using Grasshopper, so we can populate it. As you can see, in Rhino we have a bunch of arrows pointing to the direction that I want. This way, we can replace them with characters in Twinmotion. It's important that they are 3D objects, so as you will see, they will be an extrusion, and also they need to be block instances. This way, the characters keep as instance in Twinmotion as well, improving performance. I will show you quickly how to do this within Grasshopper. First, we only need a surface that matches the benches. You can do that into your modeling software, filtering them or selecting them. So, when you have the surfaces, you can populate it using the populate geometry component. So, we can use the surface area to control how many points there will be on the surface, based on their area. Connecting them directly means approximately 1 point for each square meter. For example, a surface with 100 square meters will have 100 points. We can control this proportion with a slider. After this, since the points are random, I wish them are not too close to each other, so they make enough space to place a character there. I used the cool duplicate to do that, and the tolerance can be chosen as you wish. Something like 1 point each 1 meter is good. Then, we need to place blocks on them and rotate them in a specific direction. First, let's create a block. I drew this arrow and extruded it to create a 3D surface that Twinmotion can see, using the block command. The base point is important to be in the middle of the arrow, so we can see the direction correctly. I've named it arrow. After it, we can place the block with the insert block from front using the name and the points we created. Now, just a little adjustment. So I expect that I will use like 4 characters to compose the crowd. So I create 4 new blocks definition called arrow 1, arrow 2, arrow 3, and arrow 4. Using the define block component from human. Using a random list, I can create a list that can randomly point to each block name. Now, using the insert block, the 4 arrow blocks are in the right position. The last step is to rotate them in the direction to the center of the stadium. The center of the stadium can be obtained using the bounding box component, then volume component to get the center point of the volume. If you want, you can use another point, so the crowd will have another point to center their look. Now we need to calculate the angle that each arrow needs to rotate. First, I get the y vector from every point, since it matches the arrow direction. Creating a line from each point can help us to get the angle. Creating a vertical line in the center of the stadium allows us to use the closest point on curve component, and with this line we get the direction that each point needs. Now, a simple rotate geometry will rotate each block with each calculated angle. And here it is. You now just need to bake and send it to Twinmotion. In Twinmotion, just import the model. Remember to use the keep hierarchy to keep the names of the blocks. Replacing them is easy with the Replace tool. Right-click the arrow, select all instances and click Replace. Repeat it to the other blocks and that's it. Now you can render your crowd as you want. I will show quickly how I made this render, and that's it guys. I hope you enjoy it.